Hey everyone, so this is the second half of the Objective 4 problems, which is when we have combined circuits of series and parallel. Now, in the last video, we went over how we find total resistance in the problem, where we had to do series and parallel calculations, starting with our original circuit, which then we broke down by combining these two in series. Then we combined these two in parallel, and then lastly we combined to find the total amount of resistance. Now in this video we're going to go through certain things. The problem specifically asks what is the current through the second resistor, third and fourth, and the first, but we have to take these steps that are hidden. First we have to find the total current, then we can find the current leaving the resistor. So that's what we do first. Now, to find the total current, I1, which I actually have to work already, we have to take and use Ohm's law, where Ohm's law is the current equals the voltage divided by the resistance. Now, in this problem, when we're looking at the total amount of current, the total amount of voltage is the voltage in the battery, and R total is our equivalent, what we calculated. And in this problem, it gives us that we have a voltage of 61 volts and a total resistance of 38.67. So to find the total current, we take 61 volts divided by 38.67 equals 1.57 amps. So whatever is leaving the circuit right here, I total, equals 1.57 amps. Now this current is going to leave the circuit, come around, come back around. It'll split up in between at certain times, but when it goes through, the key thing to look here is the total current comes out of the battery. It's going to first pass the first resistor, meaning the total amount of current actually passes by this first resistor. Meaning the total current, since this is in series, since the battery and resistor are in series, the total current is equal to our current in the first resistor. Since the current in the first resistor is the same thing coming out of the battery, that means our current for the total current, 1.57, is the amount of current coming through resistor 1. Now, what information does that tell us? It tells us that we have 1.7 amps worth of charge leaving this battery. And when it gets through here, it's going to use some of the energy to pass through this resistor. And then when it hits this junction, it's going to split up. Not perfectly even because we don't have equal resistors. What we have to do in this problem is before we could find out how much current it splits up to, we have to find out how much energy disappears. And how we do that is we use Ohm's law to find out how much energy leaves this resistor. Sorry, how much energy is used in this resistor. We use Ohm's law where voltage of the first resistor equals the current running through the first resistor times the resistance in the first resistor. We just found out what the current was with 1.57 amps, and the resistance was given as 15 ohms. So we multiply these two values together, and we get a value of 23.55 volts. That means the voltage in the first resistor is 23.55, and how much voltage we have left, how much is left after passing through this first resistor, how much energy that can be used in this resistor or these two, is 37.45. And it's very key you make that distinction that it's not the total voltage, it's how much is left over. Because to find out how much energy we have left over, we'll have to do some more extra Ohm's law stuff. Now, in here, we have R1, and the amount of energy we had, we just said was 37.45. Sorry, was 23.455, and the leftover energy is 37.45. And the problem asks, what is the voltage going through this resistor? Well, these two are in parallel, which if we go back to our parallel rules, V1 equals V2 equals V3, or in this case, V2 equals V3, 4. The amount of energy being used in this resistor is the same as the total amount being here. So to find that amount of energy, there's one last thing I forgot to add. V2 equals V3, V4 equals V left over. Since some energy is being used here, it can either go through this resistor and use all the energy in this, or it can go through these two and use all the energy there. Now, when we do so, we found what's left over as 37.5. This is how much energy will be used throughout these last resistors. And it's very key we find that out first, because with this information right here, we can find out what is the current going through each resistor. So we're going to look at I2. Now, I2, by Ohm's law, is the amount of voltage there is in the resistor, which we just found as 37.45, and the resistance that it's going through, which in this problem is 41. Using Ohm's law and knowing what this voltage is, we can find out how much current is there left over. So we take 37.45 over 41 ohms equals 0.913 amps. Now, that's how much is splitting off into this second resistor. Now, to find out how much current goes through these two, well, whatever passes through this resistor has to pass through this resistor as well. They're combined, they're in series. And with series circuits, everything passing through here is the same passing through here. So we'll take 37.45 divided by R234, which in this case is 56 ohms. Which when you calculate that, of 37.45 divided by 56 ohms, that is some number of 0.66 amps. Now another way we can find that is in this problem. There's 1.57 amps leaving this circuit. And part of it, specifically 0.913, goes down this first wire. Whatever's left over has to pass through this wire of 0.66. Now I know this is very complicated. We're going to have more practice next week, and that's why I made objective 4 optional, because we'll be doing a lot more practice with this next week. So I hope this is helpful to see what we'll be leaning towards.